हे एवरीबॉडी अनअकैडमी पे मेरी सबको आवाज़ आ रही है? प्लीज़ लेट मी नो। कोई प्लीज़ कंफर्म करो यार, मेरी आवाज़ आ रही है क्या? एंड ऑल्सो यूट्यूब पे मैं देख सकता हूँ कि हम लाइव आ चुके हैं। या राइट। सो ऑल आई नीड इज़ ए कंफर्मेशन फ्रॉम यू गाइस कि मेरी आवाज़ आ रही है ना? All right, so someone has just confirmed that the voice is audible. All right, great. So YouTube पे भी यार कोई कंफर्म कर दो। आई होप कि आवाज़ आ रही होगी। Yes, so someone has confirmed there as well. All right. So before we begin, let me just make it clear कि जो आज की ये वाली स्ट्रीम है ये दोनों जगह पे लाइव चल रही है, अनअकैडमी पे भी एंड यही मैं स्क्रीन शेयर करके यूट्यूब पे भी लाइव कर रहा हूँ, एज यू गाइज मस्ट बी एबल टू सी जो भी यूट्यूब पे हैं। एंड सो मैंने साइड बाय साइड दूसरे मॉनिटर पे यूट्यूब का भी खोल रखा है, तो आई ट्राई टू एड्रेस द कमेंट्स देयर एज वेल। बट जो भी थोड़ी ज़्यादा इंटरेक्शन होगी, एज एन आई विल बी आस्किंग सम क्वेश्चंस, आई विल बी लॉन्चिंग सम पोल्स एज वेल। सो अगर वैसी वाली इंटरेक्शन आप लोग चाहते हो, सो जो लोग यूट्यूब पे हैं दे कैन कम टू अनअकैडमी एज वेल इफ दे वांट टू। अदरवाइज अगर आप यूट्यूब पे कंफर्टेबल हो तो यूट्यूब इज़ ऑल्सो फाइन। ऑल राइट। सो so I hope everything is fine as of now. Someone is saying कि Unacademy is down यार, but Unacademy पे तो लोग ज्वाइन कर रखे हैं। जो लोग Unacademy पे हैं प्लीज़ कंफर्म सही चल रहा है या डाउन है, कुछ प्रॉब्लम है क्या Unacademy पे? Unacademy पे जो लोग हैं प्लीज़ कंफर्म इफ इट इज़ वर्किंग फाइन। या सम पीपल आर सेइंग दैट देयर इज़ नो प्रॉब्लम। ऑल राइट, सो ग्रेट, आई विल जस्ट कंटिन्यू इन दैट केस। अगर all right, let me just check the speed. From my end the speed is fine. All right, so before we begin, my name is Pulkit Chhabra, and this today's class will be is going to be on Dijkstra's algorithm. And by the way, if you don't know, if you guys don't know about the plus platform, your plus platform है, मैं within next 3-4 minutes I'll try to explain it to you what is it. And I'll be very soon taking graphs 2 course on the plus platform. अभी ग्राफ्स 1 कोर्स कुछ टाइम पहले ख़त्म हुआ है, कुछ टाइम पहले से, आई मीन ऑलमोस्ट अ मंथ हैज़ ऑलमोस्ट 1 महीना हो गया है। एंड ग्राफ्स 2 अभी 12th of November से स्टार्ट होने वाला है। So all right, let me just introduce myself. Let me just tell you what this platform is for all of those who are new to the platform, and then within sort of 5 to 7 minutes we'll try to begin with the session. मज़ेदार सेशन होने वाला है। It's not just about the theory. We'll also be covering a couple of questions. Like the session is the planned time for the session is 90 minutes, which is 1.5 hours. अगर एक क्वेश्चन कवर हो पाएगा तो एक क्वेश्चन कवर करेंगे, 2 क्वेश्चंस कवर हो पाएंगे तो 2 क्वेश्चंस कवर करेंगे। But sort of the first half of the session I'll sort of try to spend it on the theory part of Dijkstra's algorithm. All right, I hope it makes sense. So जो लोग नए हैं, मुझे नहीं जानते हैं, my name is Pulkit Chhabra. जो लोग ऑलरेडी जानते हैं, they may know me as coder Pulkit C from Codeforces and CodeChef and various other platforms. So I'm a final year student at DTU, Delhi Technological University. I've worked with Coordination and HackerRank in the past, and these are my credentials on CodeChef and Codeforces, as you may be able to see. ये मेरा प्रोफाइल है unacademy.com/@coderpulkitc। आप लोग यहाँ पे जा सकते हैं if you want to take a look at other special classes that I have took so far, and mostly जो classes हैं वो graphs पर ही हैं, बट आई थिंक एक दो हैं जो डायनामिक प्रोग्रामिंग पर भी कुछ प्रॉब्लम सॉल्विंग सेशन कर रखा है एक, एंड बट मोस्ट ऑफ देम आई टेकन ऑन सॉर्ट ऑफ ग्राफ्स एंड ट्रीज ओनली। ऑलराइट, सो ये जो सॉर्ट ऑफ कॉम्पिटिटिव प्रोग्रामिंग का नया प्लेटफॉर्म है विच CodeChef and Unacademy have come up with in collaboration with each other. So just a second, let me just connect the pen tab. Yeah, So this platform is basically something which will give you live interactive classes just like this one. Doubt support. There's Shrikant with us, who is actually a 7-star coder on CodeChef, and he'll be taking up the doubts today. And there are practice problems relevant to each each course on the CodeChef platform. For example, जैसे कि मैंने बताया कि मैंने ग्राफ्स 1 कोर्स लिया था, so I sort of made sure कि कम से कम ग्राफ्स 1 से related there are at least 60-70 problems that are being discussed, either discussed or being given for practice, so that the doubts can be asked and TAs can resolve them. All right, so yeah, ये 3 major चीज़ें हैं. And I think I'll also sort of tell you a little bit about the educators, because I think whenever any learning platform like this one comes up, educators are one of the most important things. So the educators have very strong competitive programming background, and not only that, they do have an experience in educational training as well, because I think कि एक अच्छा competitive programmer होना is not the only thing that's required for someone to be a good teacher as well. So yeah, they have sort of made sure कि दोनों चीज़ें हों. Personally for me, I have been before sort of joining Unacademy and CodeChef, I have prior experience in teaching, as in I sort of used to upload videos on YouTube, and solution videos of various Codeforces contests. And I had also sort of had a course of my own, a competitive programming course of my own, and I did also work with another education institute beforehand. Alright, so enough about this. So many of the educators are ICPC World Finalists, IOI medalists, and if some of the people are not that, they have sort of really great ratings on platforms like CodeChef and Codeforces. And out of all the educators that are there as of now, according to what I am aware of, I think it's just me and Nishche who are in college right now. Apart from us two, rest all of the educators are working in top companies of the world like Google, Facebook, LinkedIn, Amazon, and so on and so forth. All right, so this is sort of a list of educators. Some more have joined us now. This PPT is a little outdated, I'm sorry for that. So there's Deepak and Himanshu, who are ICPC World, who sort of were selected for ICPC World Finalists this year. I think they both were in same team. There's Arjun and Murugappan. Arjun here is IOI bronze medalist, and Murugappan is a software engineer at Google, and these are his maximum ratings. There's Triveni and Tanuj. Triveni also has been to ICPC World Finals, and Tanuj has been to World Finals twice, and he has worked at Google and Facebook and so on and so forth. There's Riya and Sanket. These two guys have Sanket and Riya have a very good experience and a strong and a strong hold on teaching. They have a very good background in teaching and mentoring students. There's Nishche, and Nishche here is one of the highest rated coders in India. I think consistently among top 5 on Codeforces, and I think currently he's among top 3 if I'm not wrong. I'm not sure, but consistently among top 5. That's something that I can say for sure. All right, and this me. So these are the topics that are being covered. These slides will also remain after the after the class as well, so you can have a look, or maybe take a screenshot if you want to have a look at this. All right, so these are some of the courses that started and have sort of ended. Greedy Graphs 1, like I said, Introduction to Number Theory by Nishche, and Recursion and DP, Searching and Sorting, C++ STL, and so on and so forth. All right, so like I said, teaching assistant support on chats and doubts platform. This is the CodeChef doubt platform. Apart from this, there's also a Discord server for the people who have subscribed for the Plus, and TAs and even educators are active there for answering any doubts that any student may have. All right, so like I said, there are course-wise practice problems like this one. There's a different contest set up for each course. This is a sort of just a second. Yeah, so this is the course for trees and graphs. As of now, I think there will be around 30 problems here, and apart from that, I have given a lot of other problems as well for practice from different other platforms. All right, so regarding the fee for the platform, for the plus platform, it is not like, I'll just get rid of this one because this is a standard fee. And if you use this referral code called, just a second, Pulkit CP, you will be able to get 10% off in each of the plans, in each of these three plans. All right, so the subscription policy is like, it's not like that you'll be subscribing for different courses. It's an all-in-one subscription. You subscribe for competitive programming. You have access to each of the courses that have already ended, the recorded lectures of those courses, and you will be able to access all those courses live which are going on right now. All right, so many more things are also coming very soon. And like I said, there's another course, graphs 2, which I am going to start in another 5-6 days. Yeah, so you can have a look at the platform, play around with it, and see how much do you like today's class. And this is the experience you'll have if you sort of decide to buy the platform. Yeah, you can also sort of have a look of the other special classes which are again free, and sort of decide accordingly. So I'll be moving on from this slide now. So I'll just write the referral code which can help you get a 10% discount on the platform if you wish to enroll. All right, so yeah, this is it, the introduction part. Now I am planning to begin with the main topic. So before that, if you guys have any questions regarding the platform or any suggestion regarding covering the topic, I'll be happy to answer. I'll wait for 30 more seconds to allow you to come up with any questions that you may have. I am looking at YouTube and Unacademy simultaneously. Okay, so someone is asking, is it necessary to do CP to get job to in big companies? Necessary is a strong word, but it does give an edge according to me. Necessary, no. Helpful, yes. I hope this answers your question. Please teach all. Yeah, don't worry. I'll teach the variations. Yes, Harsh, it will be covered. Don't worry. Okay, so someone is asking if is CP used in real world software dev also. In whatever little experience that I have gained in software industry, I think the percentage of CP being used in real software dev, like as a part of the job that we'll be doing, is not going to be that much. Only sort of the people who have a lot of research, research background and sort of all those things. I think those are the people who are involved more in algorithm making of big decision making related to algorithms in different parts. And to answer your question in a short manner, I think not much. All right, so is beginner be comfortable to learn this algorithm? So the prerequisite for today's class is sort of, you must have some basic idea about graphs. Even if you do not have any idea, you can try and follow through the class. If you do not understand, maybe you can leave the class if you want to. But there is also another special class which is basics of trees and graphs. If you sort of do not understand what's going on in the class, I'll recommend to watch that video and then watch this video. That basics of trees and graphs is also available on my profile itself, which is unacademy.com @coder_Pulkit_C. So according to me, how much time will, this is the last question guys that I'm taking. With after this I'll dive into the question. Any other questions I'll take after the class if time permits. According to you, how much time will it take someone to become good in CP for beginner? Again, yeah, it is also a very subjective question. It depends on the definition of your good. Depends on your definition of good. And for beginner, and again, it depends on how much effort and smart work does the person put in. Again, I'll not let you sort of keep hanging around, and I'll just answer it. So on an average, I don't know, I think it requires at least 6 months according to me. At least 6 months according to me. Again, depends on person to person. All right, so just a couple of answers questions I'll answer on YouTube, and then I'll just move on. So is there any Diwali offer? I'm not aware of that as of now, Roshan. I'm sorry, I won't give you any wrong information. I'm not aware of anything like that right now. Where we uses Dijkstra's algorithm. So yeah, I'll be covering a couple of problems today, one or two problems. You'll get an idea. Can you cover Bellman-Ford? Okay, I'll try to have a lecture about that in future, but not in today's class. Okay, so the videos on YouTube are uploaded in sequence. I don't understand what do you mean by sequence. Someone is asking, he's in 4th sem and haven't learned anything about CP stuff. Can you guide us through the path of DP algo learning? I think it will be better to sort of watch some video regarding this aspect only on the CodeChef channel itself. I think there are videos like Introduction to CP and etc. etc. I'll suggest you to watch any of those videos. Okay, great. सो एक्सपर्ट बनने के लिए हैकिंग भी आनी चाहिए? नहीं, ऐसा ज़रूरी नहीं है कि हैकिंग भी आनी चाहिए एक्सपर्ट बनने के लिए. हैकिंग इज़ जस्ट लाइक डिबगिंग. तो कोड डिबग करो, दोस्तों में से कोई डाउट पूछता है तो देखो उनका कोड में क्या गलती है, या फिर अगर सीखनी या फिर एज इन प्रैक्टिस ही करनी है तो देखो कुछ लोगों की रॉन्ग सबमिशन उठा के और उसमें गलती ढूंढने की कोशिश करो, सो दैट योर डिबगिंग स्किल्स बिकम बेटर. ऑल राइट, सो इनफ फॉर नाउ. ऑलरेडी 15 मिनट हो चुके हैं. Let's just get the topic over with. Let's get. तो फिर उसके बाद we'll sort of come back and see अगर हमारे पास टाइम बचता है तो I'll answer some more questions. All right. So the agenda for today. All right, great. So the normal sort of standard version of Dijkstra's algorithm that we know, the question that it answers is basically for a weighted, either undirected or directed graph, that what is the shortest distance for each node from a particular node. So if I am to sum it up in sort of one sentence, it finds for us single source shortest path or distance. You can either say path or distance. All right. Again, so it works for undirected or directed both, and it also works for any of these, either unweighted or weighted, right? So this is what this algorithm solves for us. So far so good, I hope. Any like just via show of thumbs up, I sort of keep asking this question ताकि ऐसा ना हो कि मैं खुद से ही बात करते जा रहा हूँ. All right, great, that's enough. Sure. Okay, so sure. So how does this do it? The idea behind this algorithm is, for now, let's say we have weighted undirected graph. I'll answer this question. Yes, it can be used. I'll tell how. I was just talking about the standard sort of version without any variation. All right. For those who don't understand, I'm answering the question of Shri that has been asked on Unacademy. All right. So as of now, I'll be discussing the single source, and then we'll move on, and I'll tell you how do we do for multi-source and how does it work. Great. So as of now, we have a single source and we have a weighted graph, right? And we want to find the distance of each node from that particular source, the shortest distance for each node from that particular source. So what do we do is, what can we do is, we can sort of start with the source itself, right? And then have n iterations. Why n iterations? Because there are, let's say, n nodes. Let's say there are n nodes total. All right, and S is our source node. Source node. So what it does is, n nodes, let's say S is our source nodes. So for x belonging to 1 to n, someone is saying my video is getting struck. Is it the case for everyone? And also, if my audio is fine, I think video is not going to sort of affect the learning part that much. Okay, so other people are saying that it is crystal clear, so I think there is there's a network issue at your end, Shri. So for x belonging to 1 to n, so n times ये चीज़ करते हैं Dijkstra's algorithm में. कौन सी चीज़ करते हैं? At every iteration what we'll do is, we'll get the shortest distance wala node as of now, right? So initially we'll have a distance array wherein we'll assume the distances of each node. All right, so पहली बात तो ये क्वेश्चन में आती है कि assume क्या करें पहले. तो what we do is, initially हम क्या करते हैं, डिस्टेंस array हमारे पास होता है such that distance of जो source है उसको हम रख देते हैं 0, because सोर्स से सोर्स पे जाने का डिस्टेंस तो 0 ही होएगा. एंड व्हाट वी डू इज, जो बाकी के सारे डिस्टेंसेस हैं फॉर ऑल अदर नोड्स, डिस्टेंस ऑफ आई को हम रख देते हैं इन्फिनिटी. अब यहाँ पे इन्फिनिटी का कोई सेंस नहीं बनता है. बाय इन्फिनिटी व्हाट आई मीन इज अ वेरी लार्ज नंबर. अ वेरी लार्ज नंबर से व्हाट आई मीन इज, लेट्स से हमें पता है कि एज वेट का कंस्ट्रेंट क्या है. इसको, इस बात को ध्यान से सुनना. मान लो हमें पता है कि जो एज वेट्स हैं दे कैन बी अप टू 10⁻³ and let's say we know that the number of edges that we have, or let's say the number of nodes that we have are 10⁵. तो अगर हमारे पास number of nodes 10⁵ हैं और जो edges के weights हैं वो 1 से 10⁵ तक हैं, so that way we can be sure कि किन्हीं भी दो का जो distance है वो 10⁸ से exceed नहीं करेगा. तो we just have to find a number greater than 10⁸ and उसको distance of i के बराबर रख दो. So we just need a number big enough such that के कोई भी डिस्टेंस उससे बड़ा ना हो, राइट? सो या इन सम केसेस इंट मैक्स में बी द आंसर. बट अगर मान लो कि हमारे पास 10⁵ नोड्स हैं और हर एज वेट जो है वो 10⁹ तक हो सकता है, तो उस केस में इंट मैक्स भी काम नहीं करेगा, बिकॉज इंट मैक्स की वैल्यू इज क्लोज टू 2 × 10⁹. एंड इस केस में लेट्स से इफ द एज वेट इज 10⁵ and number of edge weight is 10⁹ and number of nodes are close to 10⁵. so maximum जो हो सकता है वो 10⁻14 के आसपास का हो सकता है. तो थोड़ा सा ध्यान रख के समझ पा रहे हो ना, तो उस हिसाब से ये इन्फिनिटी की वैल्यू डिसाइड होती है. वी जस्ट हैव टू मेक श्योर कि ये वैल्यू इज ग्रेटर देन एनी अदर पॉसिबल path length. All right, so initially we put the source of the distance of source as 0 and the distance of every other node as infinity. All right, so n times ये चीज़ करते हैं. क्या करते हैं? n times what we'll do is get and also we'll have another array marked और या फिर visited, ठीक है? और mark of i equal to 0 इनिशियलाइज कर रखा है हमने पहले से हर एक के लिए. एज इन अभी हमने वो वाला जो नोड है उसको एक्सप्लोर नहीं किया है. ऑल राइट, सो एवरी नोड इज मार्क्ड 0 इनिशियली. सो व्हाट वी डू इज इन ईच इटरेशन, आउट ऑफ ऑल द नोड्स दैट आर अनमार्क्ड एज ऑफ नाउ, ठीक है, जो भी अनमार्क्ड नोड्स हैं उनमें से मिनिमम डिस्टेंस वाली नोड लेके आते हैं. सो आई थिंक ये तो बहुत ही ज़्यादा क्लियर होगा ना कि सबसे पहले जो मिनिमम डिस्टेंस वाली नोड आएगी फर्स्ट आइट्रेशन में वो सोर्स नोड ही आएगी, बिकॉज बाकी सबको तो हमने इन्फिनिटी मार्क कर रखा है, सिर्फ सोर्स नोड को 0 मार्क कर रखा है. सो एनीवे सेकंड टाइम कोई और आएगी, थर्ड टाइम कोई और आएगी, दैट विल डिपेंड फ्रॉम ग्राफ टू ग्राफ, ठीक है. सो गेट द अनमार्क्ड नोड with min d वैल्यू, ठीक है। सो लेट्स से जो नोड आई हमारे पास आई, ठीक है। सो उसके बाद व्हाट वी विल डू इज, अब इसका मतलब ये है कि करंटली अकॉर्डिंग टू sort of the current scenario, I is the closest unmarked node from the source, right? So उसके बाद हम क्या करेंगे, उसके बाद ना जो बाकी की सारी बची हुई नोड्स हैं जो कि अनमार्क्ड हैं, जो भी देखो, जो भी नोड ऑलरेडी मार्क्ड होगी उसका डिस्टेंस आई के डिस्टेंस से छोटा ही होगा, तभी वो पहले ही मार्क हो गई। ध्यान से सुनना है इस बात को, थोड़ा सा समझने में मुश्किल आ सकती है, मैं इंट्यूटिवली समझाने की कोशिश कर रहा हूँ कि डिजिक्स्ट्रा कैसे सही से काम कर रहा है, ठीक है। सो थम्स अप के थ्रू या कन्फ्यूज के थ्रू मुझे बता सकते हो, और कोई क्वेश्चन हो तो वो भी पूछ सकते हो, अगर समझ आए तो भी यू कैन राइट इट ऑन द चैट कि अच्छा समझ में आ गया, कैन मूव ऑन। सो लाइक आई सेड कि अगर कोई नोड अभी इस पर्टिकुलर लेट से एक्स आइट्रेशन में हमने सेलेक्ट की, तो व्हाट आई एम सेइंग इज कि जो भी नोड्स का डिस्टेंस इज लेस देन द ओरिजिनल शॉर्टेस्ट डिस्टेंस इज लेस देन द ith नोड का डिस्टेंस, वो ऑलरेडी मार्क हो चुकी होंगी, है ना। सो व्हाट वील डू इज, अब जो बची हुई नोड्स हैं, है ना, जो बची हुई नोड्स हैं, okay, someone is saying repeat this part again, I'll just repeat what I am saying is कि जिन भी नोड्स का डिस्टेंस, जिन भी नोड का शॉर्टेस्ट डिस्टेंस is less than the shortest distance of I from the source node, they would have already been marked because the distance is shorter, right? So what I am trying to say is, out of all those nodes having a greater distance, which are unmarked as of now, they in a way have two possibilities. One possibility is that for moving from source node to that particular node, one particular possibility is that the path does not comprise of the current node, the ith node. The other possibility is that it passes through the ith node. So what I'm trying to do here is that we get the node with the shortest distance as of now, we get the unmarked node with the shortest distance as of now, we mark it true, we mark it, so mark of I equal to 1, and then what I'll do is I'll iterate over the adjacency list of this particular node. So for sort of int neighbor belonging to the adjacency list of node I, I'll just say that, hey, whatever the distance value you are possessing right now, it is assuming that you do not pass through the ith node, but it is possible that if you use this edge which goes from I to neighbor, you actually end up getting a better distance. So what I'll simply do is d of neighbor equals to min of d of neighbor comma d of I plus the weight of edge, all right, weight of the current edge. So it will basically not be an integer, it will be let me just rephrase it, let me just rewrite it. So it is not exactly, it is an edge. So one thing is neighbor, which is e dot first, all right. Another would be weight, which will be e dot second. So okay, Shrikant, yeah, I'm sorry I missed that. Okay, I'll try to speak in English. Thank you for letting me know. All right, so the neighbor is first and the weight is second. I'm sorry for the bad handwriting, I hope it is at least readable. All right, so what I'll do is d of neighbor is equal to min of the distance that is already there with us, or if we try and visiting that through this particular node, so weight plus d of I. All right, so this is what we do, this is what the Dijkstra algorithm does. Just let me know what has been written. Is it clear to you? Like, is it readable at least? Okay, so yeah, so I think it is I think let's try to sort of understand what I'm trying to do here using an example. So it'll make you guys understand this better. Regarding typing, someone is asking me to type. There's not an option to type, man. I'm sorry about that. So let's say we have this graph. Just a second. Let me just find a very suitable example. All right. So let's say we have 1 and then 2 using this node, and then we have 3. Let me just, yeah, let's say then we have 3 and this edge weight is 9, and then we have 10 here, and let's say 6 and 5 and 4, yeah, so 15 and 11 and 6, 9, 2 and 14. All right, so I think it is a big enough graph which will explain the algorithm. So I'll just write it down, write the weights more clearly, and this is 5. All right, so let's say this is our source. This is our source. Okay, let me color it using blue. All right, so all of these nodes are initially unmarked, and like we know, the distance of this node is 0 and all the other nodes are having a distance of infinity. All right, cool. So out of all these nodes, we know that 1 is the node with minimum distance, right? So we'll find this node, mark it, right, and then we'll visit its neighbors and do this operation which is called the relaxation operation. This operation, we call it relaxation operation. All right, relaxation operation. So iterate over its neighbors. What are its neighbors? 2. All right, 7 is less than infinity, so I'll just replace it by 7. Again, infinity say chota hoega 9, so I'll just replace it by 9, and again this 6 for this infinity will be replaced by 14. Makes sense, right? Makes times as of now. All right, so just a second, let me just see. Okay, so so you're saying that continuing in English. All right, we'll definitely consider this. So how much does it take for 1 month subscription? I think Srikanth will answer that. All right, I'll just continue. So again, one iteration has been done. Now again, we'll look for the node with smallest distance. Out of the unmarked nodes, we can see that now we'll be moving for this node 2, right, because it is having the shortest distance. So now again, out of when we'll be doing the relaxation operation for the edges, for the nodes which are in the which are the neighbors of this 2, we'll see 1, but the distance of 1 is already smaller, so it will remain 0 only. Something that I need to sort of make you understand is that whenever we are doing the relaxation operation, none of the unmarked nodes will be updated, because unmarked nodes anyway have a distance shorter than the distance of the current node, right? Because this marked node, I'm sorry, I think I said unmarked, but I meant to say marked. This marked node 1 will already have a shorter distance than the distance of 2 itself. All right, so it is no way going to be updated anyway, so this 1 is not going to be updated. Then we go to 3. The original distance that we have is the current distance that we have is 9, and the distance proposed is 7 plus 10, so it will remain 9. Again, this 4 basically has a distance of infinity initially, infinity right now, and the proposed distance is 7 plus 15, which is 20, no, 22. So this will be updated to 22. Cool. And yeah, then again we'll look for node, the unmarked node with smallest distance, which will be 3 in this case, right? Then again, going to the neighbors of 3, moving to 1. So the distance that we already have is 0, and the proposed distance is 9 plus 9, which is 18, so no updation. And again for 2, the distance that is there is 7, and the proposed distance is 9 plus 10, which is 9 plus 10, which is again 19, so no updation. For this 6, now initially the distance is 14. Again, the other way could be that what if we visit 6 through 3? So if we visit 6 through 3, the distance will be 9, because the distance of 3 is 9 here, plus 2. So now we can see that yeah, this particular option is a better option. So we erase this 14 and replace it by 11. Great. So yeah, the other neighbor that has been left is 4. For 4, the distance that we currently have is 22. Again, if we visit 4 through 3, the distance that we'll have is 9, which is the current distance of 3, plus this edge weight 11, which is 20, again a better option. So replace this 22 by 20. Then no, it ensures shortest path from any node to any other node. I think I did not understand your question completely. If I fix a source and then I find the shortest path to all the other nodes, it will give me the shortest distance for every node from the source node. What do you mean by from any node to any other node? Please clear this so that I can answer your question. All right, so now 3 has been done, right? So 3 had this 4 neighbors, all of which have been covered. Now in the next iteration we'll have this 6, because 11 is the shortest distance out of all the unmarked nodes. And yeah, so again for this 6, we have these neighbors. So 1, no, it will not be updated. 3, no, not be updated. 5, yes, it will be updated, because the distance that we have is infinity, and via 6 we'll have 9 plus 11 plus 9, which is 20. So infinity is gone, 20 is now the new deal. All right, so someone is asking, can I explain about the visited nodes distance update? So what I was telling that now is that what I was telling at that point of time is that whenever we are a particular node, let's say when we are at this node 6, but I was just saying that if you notice, all of the visited nodes, in this case 1 and 3 are neighbors of 6 and have already been visited. They'll not be updated. Like we'll check to update them, but they'll not actually be updated, because the distance of those nodes is already smaller than the distance of the current node. For example, 9 is smaller than 11 and 0 is 11. 0 will be smaller than 11 for sure. So they'll not be anyway updated. That's what I was just trying to say. So anyway, let me just continue. 6 has been done. Now out of the nodes that we have, 4 and 5 both have the same distance. So any one of these can be chosen. All right, so any one of these can be chosen. So let's say 4 is chosen, and once 4 is chosen, then again the neighbors of 4, 3 and 2. So 3 has a distance of 7, which is smaller than 20 plus 15. 2 was a distance of 7 which is smaller than 20 plus 15, and 3 also has a smaller distance. And regarding this 5 also already has a smaller distance which is 20, and the proposed distance is 20 plus 6, so no updation. Then again this last node which is 5, for 5 as well we'll choose 5 and try to make the relaxations, but no relaxation will be actually made because the distances will already be smaller. So these will be the final distances that we will get, and these will be the shortest distances from the node 1. All right. So yeah, does the algorithm make sense to all of you guys? Yes, Gagandeep, we are actually going to sort of move to that part right now. I am just talking about the algorithm being clear or not. Yeah, we are going to cover the time complexity and better approaches. I am just talking about the algorithm right now, buddies. All right. So Shadi Singh, does this ensure that we set one of it minimum before we go to other node through it as been counted? Yes, that's exactly what I was trying to tell you, Shad, because when, like, okay, let me just sort of speak. So what is happening here? Whenever we are at a particular node, let's say when we had chosen 6, right? When 6 was our chosen node, for example, what I am trying to say is when this I was 6, right? So what I am trying to tell you here is whenever a particular node is a chosen node, all of the nodes having the actual shortest distance smaller than the actual shortest distance of 6 have already been found. The distance, the d value, the distance value of all the other nodes which are having a shorter distance are already been set to the original shortest distance. So since we have already found the original shortest distances of all the nodes having distance smaller than myself, I'll also be able to find the smallest original distance of the current node using those nodes. I hope it makes a little bit sense. It is sort of tricky, but does it make sense a little bit? I'll explain it once again, Arayar. So initially set every distance to infinity because we do not know the distance as of now, and we'll keep taking minimum. So every node's distance is set to infinity initially, and the distance of source is set to 0, right? So and every node is being marked 0 initially, right? So whenever we are yeah, I think I'll be explained to I'll be sort of able to explain better in Hindi, but people are saying I should speak English. It's okay, I'll try to explain in English itself. So whenever we are at a particular node, initially what do we want from initially? One of the edges that will be used, that will be act as the first edge, will be one of the edges that are connected to the source node itself, right? For example, in this case, the one of the first edges, the first edge that we will traverse for going to any of the nodes, it is going to be any of these 3 edges only, right? इन तीनों में से कोई ना कोई एक एज होने वाला है. So so the thing is कि whenever we are trying to explore these edges, the distance of the distance of the source node, which is 1, is already being set to its original distance, right, which is 0, because हमने पहले से इसको 0 कर रखा है, right? Then out of all these 3 nodes will anyway get the node with the minimum distance, in this case 7, right? So when we have this node with with distance 7, if any of the other nodes had a better possibility through 2 than otherwise, right, they'll be updated to the better distance. For example, अगर यहाँ पे 9 की जगह let's say 15 होता, let's say यहाँ पे 15 होता, and let's say यहाँ पे we had let's say 5, so यहाँ पे पहले 15 होता, but जब हम 2 पे आते और 2 के एजेस के साथ रिलैक्सेशन ऑपरेशन कर रहे होते, when we would be doing relaxation operation using the edges of 2, we would have already updated the distance of 3 from 15 to 12. 7 plus 5 equals to 12, so it would have been updated from 15 to 12. So that's what I'm trying to say. By the time we reach that particular node, the distance of that particular node will be updated. After multiple relaxations, it will be set to the original shortest distance. All right. So since we have the original shortest distance of that particular node, whenever that node is selected as the node with minimum distance, the relaxation operations that we'll be doing the relaxation operations that we'll be doing will be giving us the actual distances to the neighbors, and not just the not just arbitrary distances. So Shri is saying, I think you are not marking using mark of I statement in the pseudocode. I am marking mark of I equals to 1. Shri, is it fine, or did I miss anything? Please confirm, Shri. You said that I am not marking, but in this statement I think I am marking. Is this something I am missing, or is there something you missed? All right, so Shri is not writing, so I'll just let it go. Great. So I hope the algorithm is clear now. Please let me know if the algorithm is clear. We'll discuss things like time complexity and how to make it better, and the multi-source part. But is the basic algorithm clear? Yes, Bhupendra, I understand. Even I'm more comfortable in Hindi than in English. So someone is saying that you have marked, but what's the point of marking it? The point of marking it is that because if we do not mark it, then every time we'll end up selecting this 0. We need to know that these nodes have already been processed, and next time when we get the minimum distance wala node, we make sure that we get only one of the unmarked nodes. That is why we need to mark it. Is it understandable now, Shad and Shri? Yes, Gagandeep, sort of. I think thoda similarities hain. It's just that it's just that ki sort of we try to explore the nodes in increasing of order of their shortest distances in this manner, and in this algorithm as well, and in BFS as well. So BFS में क्या होता है कि हमें क्यू में ही वो हमेशा इस तरीके से रहते हैं कि शॉर्टेस्ट वाले पहले हैं और ज़्यादा डिस्टेंस वाले क्यू में पीछे हैं. बट इन दिस केस ऐसा ज़रूरी नहीं है, बिकॉज ऐसा भी तो हो सकता है ना कि ये वाली जो जैसे मैंने भी दिखाया कि ये जो 1 से 3 वाला जो एज है मान लो वो बड़ा होता, बट 1 से 2 से होकर 3 पे वो एक्चुअल में शॉर्टर डिस्टेंस से पहुंच जाता. सो वी नीड टू सॉर्ट ऑफ हैव दिस एक्स्ट्रा इटरेशन टू फाइंड द नोड विद द स्मॉलेस्ट डिस्टेंस एज ऑफ नाउ. ऑलराइट, सो अभी के लिए जो ये वाला मैंने सूडो कोड लिखा, इसको कोड तो नहीं करूँगा मैं. सो okay, so Shubhankar is saying, but the question is when some node is marked, okay, yet the distance may be updated. No, Shubhankar, once the node is marked, yes, yes, Shrikant, you are saying what you are suggesting is right, and I'll just also focus it. I am getting the unmarked node. Get the unmarked node with minimum D value, with minimum distance value. So Shubhankar, that's what I have been trying to explain here for the last 15 minutes. Ki by the time a node is marked, it will have yeah, I understand, Shrikant. So I'm answering Shubhankar now. What I am trying to tell here is by the time the node will be marked, its distance value, its dist value will be updated टू द ओरिजिनल शॉर्टेस्ट डिस्टेंस वैल्यू। यही तो मैंने समझाने की कोशिश की ना यार यहाँ पे, कि मान लो ये 3 की वैल्यू है, एग्जांपल लेके बताया मैंने कि मान लो इनिशियली इसकी वैल्यू हमने 15 सेट की होती, इफ दिस एज वाज हैविंग अ वेट 15 एंड 2 and 6 would have been 11 and 2 only, 11 and 7 only सॉरी, एंड देन जब हमें 7 मिला होता तब 7 के थ्रू हमने अपडेट करके उसको 12 कर दिया होता। सो बाय द टाइम दिस node is actually marked, we will have its original distance value, the original shortest distance value. So this is what you need to sort of have the clarity about. All right, so I think enough about the algorithm. थोड़ा सा अब देखते हैं कि इसकी टाइम कम्प्लेक्सिटी क्या होगी एंड इसका how can we improve the time complexity. So this is the pseudo code. I'll just write the options for you here. For the time complexity, let's say the number of nodes are n, and what I'll be doing is to have this to get this, I'll be iterating over the D array. Just let me make sure, listen to this carefully because I'm going to ask you guys this question. I'll be iterating over the D array to get this value. So what will be the time complexity? Order of n plus m, order of n plus m square, order of n square plus m, order of nm. So you have these four options. Tell me according to you what should be the answer. What will be the time complexity? This is the question, Ardindu. And just to make sure, to do this step, I'll be iterating over D array. All right. So I have some answers, but most of the people have answered not the correct option. So the correct answer is this. How? Let's just take a moment to look कि हम क्या कर रहे हैं. जो outer loop है वो 1 to 1 चल रहा है, right? 1 to 1 चल रहा है outer loop, and I'll be for every iteration I'll be getting the smallest distance वाला unmarked node, उसके लिए of n लगेगा, right? So n for this, तो n square तो इन loops के लिए लग रहा है, और बाकी ये वाला loop भी चल रहा है हर बार, ये वाला loop भी चल रहा है हर बार, So जो ये वाला loop है, जो अंदर वाला loop चल रहा है, ये क्या कर रहा है? अगर तुम नोटिस करो, एट एवरी इटरेशन जो भी आई नोड सेलेक्ट होगी वो एक डिफरेंट नोड होगी, राइट? सो पहले सोर्स नोड सेलेक्ट होगी, फिर कोई और नोड सेलेक्ट होगी, फिर कोई और नोड सेलेक्ट होगी, एंड मतलब बेसिकली एवरी नोड विल बी सिलेक्टेड वंस while iterating from 1 to n. So what we are doing is we are just iterating over the adjacency list of each node, राइट? पहले हम सोर्स नोड की एडजेसेंसी लिस्ट पे इटरेट करेंगे, फिर सेकंड इटरेशन में हम किसी और नोड की एडजेसेंसी लिस्ट पे इटरेट करेंगे, एंड सो ऑन एंड सो फोर्थ. सो इन टोटलिटी this inner for loop which iterates over the adjacency list of I will run m times, basically 2 into number of edges times. So this is why this will be the time complexity, O of n square for these loops plus O of m, because this loop will in totality run these many number of times. So is the time complexity clear now to you guys? Please let me know if the time complexity is clear. Even if it is not, tell me that it is not. Okay, I'll just repeat. So all right, so people are saying that it is not. So देखो यार, what we are doing for x equal to 1 to n, right? And then I am having this I0, and then we are iterating for I belonging to 1 to n, and then if d of I is greater than d of id, so what I will be doing is I equals to id. All right, so after this particular line, what we are doing is for auto e belonging to adjacency of I, do something, right? That's what we are doing. इतना तो क्लियर है, ये तो क्लियर है. पहले हमने n टाइम राइटरेट किया, फिर हमने n टाइम राइटरेट करके i की वैल्यू निकाली, एंड यहाँ पे एक्चुअली एक चीज़ मैंने मिस कर दी, एंड मार्क ऑफ i d equals 0. So unmarked में से I got the value of the smallest distance value. All right. So अब यहाँ पे मैं तुम्हें समझाने की कोशिश कर रहा हूँ कि ये वाला जो लूप है, ये ये n टाइम चल रहा है. इस n टाइम्स लूप चलने के अंदर एक n टाइम्स का और लूप चल रहा है, तो O ऑफ n स्क्वायर तो है ही, n इंटू n, O ऑफ n स्क्वायर तो है ही, O ऑफ n स्क्वायर तो है ही, प्लस कुछ और है, ग्रीन में लिख देते हैं. सो O of n square plus. So now somebody may think कि this is going on n times, and अब ये सोचो कि ये n times चल रहा है, which is fine, but ये वाला लूप इसके अंदर तो नहीं चल रहा है. ये वाला जो लूप है वो इसके अंदर चल रहा है, और ये वाला लूप कितनी बार चल रहा है? ये वाला जो लूप है ये टोटल n टाइम्स चल रहा है, एंड बट इस लूप के अंदर जो नंबर ऑफ इटरेशंस हैं वो कितनी है? डिग्री ऑफ i. ये क्लियर है? द नंबर ऑफ इटरेशंस ऑफ दिस लूप विल बी इक्वल टू डिग्री ऑफ i. बाय डिग्री ऑफ i बेसिकली आई मीन द नंबर ऑफ नोड्स इन adjacency लिस्ट ऑफ i. सो कैन आई से दैट इन टोटलिटी this loop will run 2 into m number of times, because it will basically run degree of 1 plus degree of 2 and so on and so forth up to degree of n, which is equal to 2 into n. So the time complexity will be order of n square plus n. अब बताओ, अब क्लियर है? ऑल राइट, सो अब क्लियर है. सो नाउ अगर तो लाइक ये है इस एल्गोरिथम की टाइम कॉम्प्लेक्सिटी. नाउ द थिंग इज व्हाट वी कैन हैव इज, हम हर बार टू गेट द nodes with the smallest distance out of the unmarked nodes, we are iterating over the whole array. To solve this thing, we do not need to iterate over the whole array again and again. We can simply use a set or a priority queue, right? So set or a priority queue can be used to do this. How वो I think थोड़ा क्लियर हो भी रहा होगा. जो s dot begin होगा, that will give me the smallest current element, and I can sort of do it n times, right? So yeah, let's just try and implement that approach. मैं उसको वाइट बोर्ड पे आई मीन ब्लैक बोर्ड पे नहीं समझाने वाला हूँ अभी के लिए. वो काफ़ी इजीली आई थिंक समझ में आ जाएगी, बिकॉज अगर ये वाली क्लियर है तो वो वाली भी समझ में आ जाएगी. उससे टाइम कॉम्प्लेक्सिटी इंप्रूव हो जाएगी, एंड विल सी कि उसकी टाइम कॉम्प्लेक्सिटी क्या होगी. लेट मी जस्ट शेयर माई स्क्रीन एंड इम्प्लीमेंट दैट अप्रोच. All right, so let's say we have this, I hope my screen is visible to you guys. So let's say we have this n and m, and then we'll have edges int u, scene uv. I'm having an undirected graph as of now. just give me a minute. I'll just try. I'll just open an Unacademy app on my phone so that I can see your comments as well. And I'm trying to speak in English, man. Side rest. Yeah, okay, cool. So and then let's say I have to find the shortest distance from 1. All right, let's say I have this vector of vector and adj, right? And once I get the n and m value, I'll just resize it to n plus 1. Great. And now I'll have this Dijkstra's algorithm, which will give me the source value, and then I can find it. So yeah, like I said, what we'll be doing is we'll be simply using a set or a priority queue. In this case, I'll be implementing it using a set to get the shortest, get the nodes with shortest distance instead of iterating over the whole array again. All right. So what I'll be doing is in my I'll start with an empty set as of now, set int s, cool, and I'll have the distance array. Let's say I have int n here and n has been passed here, so I'll have the distance array, and the distances will be initialized to infinity as of now. All right, and what I'll do is source of distance of source equals to 0, and I'll just insert the source node to the set as of now. All right, so now what you guys need to understand here is that I'll just stop sharing my screen and explain it here. So yeah, so in the first iteration, like I said, the smallest distance will be only the source node itself, right? Because बाकी सबका जो distance होगा वो तो infinity होगा, right? So initially I just pushed source node to the set. In the next iteration, in the just second iteration, this distance with the smallest the node with the smallest distance will be going to be any of these nodes, 3, 6 or 2, because सिर्फ उनके लिए relaxation operation किया होगा, right? So again any of these nodes. In the next iteration, it can be any of these nodes or these nodes. So what I'm trying to tell you guys here is that initially the shortest distance wala node is going to be source only, then it is going to be a neighbor of either source or a neighbor of source, and then in the third iteration it is either going to be a neighbor of source or a neighbor of source, and so on and so forth, right? So I hope it makes sense. So that is why what we do is we initially just insert the source node into it. So I have just inserted the source node into the set, and I am iterating while set is not empty. So while set is not empty, so yeah, I'll just get the node. Okay, also I thought of sort of missed something. So now the thing is, I want the set to be sorted according to the distance of the nodes, right? So if I want the set to be sorted according to distance, adding only the nodes is not going to help me. I'll have to make it a set of pair so that I have the nodes itself and the distances of those nodes. So I'll just add 0, src to the set. So now I have my node as the second value of the first iterator, and then I'll erase the first pointer, right? Because why am I erasing? Because this node has been marked now. All right, so now I'll be adding sort of doing the relaxation operation for okay, again when I took the input, I forgot to take the weights as well. So u, v and w, and the edges will be added in this format: v comma weight and u comma weight. Cool. And instead of vector int, it should be vector of parent int. So yeah, so erase the distance and erase the start pointer, and then iterate over the edges of this particular node, and the neighbor value is going to be e dot first, and sorry, yeah, let me list, and the weight value is going to be e dot second. And then if d of I plus weight is less than d of neighbor, then what I'll do is I'll erase the initial values, erase the d of neighbor comma neighbor value, update the d of neighbor value, which is equal to d of I plus w, and then insert it back, d of neighbor comma neighbor, and in the end I'll just return the d array. So this is the code. Before we get down to the time complexity and everything, just let me know if it is clear. And also I'll just tell you that I have made a mistake in this code purposefully. Can anyone try and figure it out? So I can tell you that the mistake is anywhere in this for loop. Anyone? I'll just show you this as well. It will help you figure out the mistake. So this is how I have taken the input for the edges. So u dot pushback v comma w, v dot pushback u comma w, and this is how I am doing the relaxation operation. Yeah, I am just asking you to figure out the mistake now. Is there any mistake or is everything fine? You just tell me. If you are even if you are not able to figure out, just tell me if there is no mistake or is there any mistake. All right, so no one is writing anything. Okay, so some people are writing there is a mistake, some people are saying that there is no mistake. Actually there is no mistake. Like generally in my codes I do a mistake purposefully, but in this case there is no mistake. I just wanted to check if you guys were able to figure out that there is no mistake or not. So regarding this erase in set, it's not necessary, it's not necessary to check. If it does not find anything, it will not delete. In the case of set, I've always been using this code, so it does not give any error. So even if it is not present, I think it should not give any error in case of set. All right. Yeah, I'm sorry, I do not remember for unordered map what is the case, but for set I can say for sure that it will not give an error. And someone else said it should be nb d comma nb. It is also not correct. It should be d of nb comma nb, because we want the set to sort the edges, sort the sort of nodes according to their distances. So this is why distances have to be entered into the set as first values, so that it has been sorted using d of nb. All right, so yeah, this is the code. Just let me know if something is not clear. Please let me know. If everything is clear also, then let me know. we'll just quickly discuss the time complexity after this. Please write it in the chat if something is not clear, or if it is clear, then also you can indicate that to me using a thumbs up, or using chat on YouTube. I'm also having a look at the YouTube chat right now. Okay, Vikas, I can see your message that you are asking to share this code on GitHub. I'll just sort of tell you where you can get the correct code for the Dijkstra, so that you can get it from there anytime. I'll put down the link. All right. So there's no confused or no on any of the platforms. So I take it that the code is clear. I'll tell you from where you can get the code in a while. So yeah, so if we discuss about the time complexity, I forgot to discuss about the time complexity of this code. Again, have a look at what we are doing. So while s is not empty, so in the worst case, this loop is going to run n number of times, right? Because in each iteration, what we are doing is we are getting the node with the smallest distance and deleting it. So when we are deleting it, once it has been deleted, it is not going to be visited again. So each node is going to be visited at max once. All right. So this while loop is going to be this while loop is going to be iterated over n times, and in each iteration we are performing this erase function. This erase. Okay, so someone is saying you should definitely take an English course before you do courses on CodeChef. So hello, check. This class was actually supposed to be in English, man, because I do know that I am not that comfortable in English. I do need some practice, as in material beforehand before taking a course in English. This is why the course this class was going to be in Hindi. But due to numerous requests from people on chat, I tried to speak in English. I hope that is something that should be respected. Yeah, thank you. So what I was saying was that the this erase sort of line will take log n, and then we are iterating over the adjacency list of that particular node. So yeah, this particular is going to take O of log n. Why log n? Because the maximum number of nodes that can be present in the set are going to be n, so log n. And this particular for loop, like we discussed in the brute force approach, it is going to run for it at max O of 2m times. So 2m or m, because we are talking in the time complexity terms, let me write m only. Since this inner loop is going to be running for m times in totality, and these two lines are going to take log n time again. So the time complexity according to this loop is going to be m log n, right? And according to this while loop, because this erase line is here and this is going to be for n times, so n log n according to the outer while loop. So total complexity is going to be m log n plus n log n, so something of the sort n plus m log n, something like that. Maybe I may have made a small mistake out there, but I think you get the idea that it is going to be of this sort. All right. So someone is saying I'm not getting the working of the last if case. Okay, can you please explain that again? So last if case. So last if case is the relaxation operation that we did, that we discussed in the brute force approach as well. It's just that, if the distance of reaching the neighboring node using this particular, by going through this particular node gives us a better distance, we just update the distance of neighbor. So since in set we cannot directly update the distance, there is no such functionality in the inbuilt C++ set. So I'll have to initially delete the existing value and then update it and then insert it again. So that's what it is doing. And so today. Okay, so hello is saying because of the Hindi constraint. I'll consider it. I think I should also. I also think I should keep making English videos in Hindi as well, because that way I am able to explain better. I do understand your point. Thank you for thank you for bringing it up. All right. So yeah, यही है time complexity for this particular algorithm. I'll just sort of discuss a question. It'll take, I think, 15 more minutes, and regarding the multi-source, that will also be covered, don't worry. The question is related to that only, because some people did ask me to cover the multi-source shortest path. All right, so the question that we are going to discuss is that given a weighted directed graph, all right, and some nodes have a hospital in it, whereas others haven't. All right, so what we have to do is, for each node, find the distance of the closest hospital from it. Yeah, that's it. I hope the question makes sense. Is the question clear to everybody? So it has been given that n comma m, the number of nodes and number of edges, are in the range 1 to 10 raised to power 5. No, Shri, this question is actually different from that one. I did appear in that hiring challenge. I think what you mean is coordination hiring challenge, right? The coordination hiring challenge problem was different. It was not exactly this question. That question has already been discussed in one of my previous lectures. I discussed that question as well. If you want to have a look at the solution of that, you can go back and have a look. I think it is the last to last graphs problem solving, and this is different. All right, so this is the question. I hope the question is clear. If someone has any doubt in question, please let me know. The keyword is that the weight is the graph is directed. All right, so someone is asking, is it better to use this set implementation or priority queue implementation? So man, in time complexity point of view, the time complexity is same for both of the implementations according to me. But I read it somewhere that in practice, priority queue implementation works a little bit faster, although it does not make any difference in when participating in contests. But it was mentioned in that article, so I think that source is credible. So priority queue implementation is slightly faster, they say. All right. So yeah, this is the question. Again, please give me a thumbs up or a yes if the question is clear. Can we move on? All right. So yeah, again, let's say if this was not a directed graph and had it been just an undirected graph, let's say if it was the case. Let's first discuss the case if this was actually undirected. Okay, I'll just discuss this case if it is undirected. If it is undirected, what we basically need is, instead of single source shortest path, we just need the multi-source shortest path, right? Because for undirected, distance from a node to hospital is equal to the distance from hospital to node, right? But in directed graph it is not actually the case, but in undirected graph, the distance from node to hospital is equal to distance from hospital to node, right? So what we can do is, for undirected graph, I just tell you how can we use Dijkstra's algorithm to calculate a multi-source shortest path. Let's say we have multiple sources, S1, S2, S3, for example, and we have this graph and so on and so forth, right? So what we can do is to calculate the distance from each of these nodes, I'll just tell you the simplest way, basically simplest to make you understand way. What we can do is, we can add one dummy node. Let's say the graph has n nodes. Add one node of your own, n plus 1th node. Let's call this node S. So what we can do is, from this dummy node, add an edge to all of the source nodes with an edge weight 0. All right. So let's say we want to find multi-source shortest path. By multi-source shortest path, what do I mean? As in, what I want is, for each I, what I want is min of distance from source 1 to I, comma distance of source 2 to I, and distance of source 3 to I. So what I am saying is, to do that, what you can do is add a dummy node S, right? Add a dummy node S, and from that particular node S, add a zero edge weight, an edge with 0 weight to each of the source nodes. That's it. Then we can apply Dijkstra's algorithm from this new dummy node S, and we'll have what we need. Does this make sense to you? In case of an undirected graph, please clear this to me. Even if we have a directed graph, in directed graph also it will work, but it's just that in this particular question, it will give us an issue, because we do not want to find for each, we do not want to find the distance from hospital to node, but we want to find the distance from node to hospital. So we'll come back to the question, but I hope this makes sense. So when we are dealing with multi-source, okay, Shad, this is the question that I'm trying to solve, man. This is what we want to find. And this is the solution that I'm proposing. This is the solution that I am proposing. All right. So does it make sense to you now? Multi-source shortest path. All right. So this is what you can do to find multi-source shortest path. Also, now if you notice now, we don't even need to have this extra dummy node, because if you notice in the set wala implementation that we just discussed, in the first iteration we'll have the dummy node in the set. But as soon as we are done with this first iteration, when we move to the second iteration, all of the nodes that we will have will be these sources s1, s2, s3 and so on and so forth, and the distance value that we'll have is 0. So if we want to have multi-source shortest path instead of single source, so all we need is, instead of adding that one source to the set, we can just add all of the sources to the set. Does it make sense to you guys? I'll just simply update, try and show you the updated code. So what we can have is, instead of single node, we can have multi Dijkstra, and instead of a single source, in that case we'll be having a vector of sources, right? A vector of sources. So initially what we did was, we just inserted we just updated the distance of the source node to 0 and inserted that particular node in set. So now what I'll be doing is, I'll be doing the same thing for each of the sources. So for I belonging to sources, what I'll do is d of I equal to 0 and s dot insert 0 comma I. All right. So yeah, does that make sense? So अर्देंदु यार, इस क्वेश्चन का मेरे पास लिंक तो नहीं होगा. दिस इज समथिंग जो मुझसे किसी ने बहुत टाइम पहले पूछा था और मुझे याद आ गया था, मैंने क्वेश्चन डिस्कस कर लिया. आई एम सॉरी यार, लिंक तो मुझे नहीं पता. All right. So multi-source Dijkstra wala people are saying that it is clear. So now let's just come back to the original question that I gave you. अरे बट कोडेगन में नहीं है ना ये प्रॉब्लम. दिस इज नॉट अ कोडेगन प्रॉब्लम. एंड ऑल्सो कोडेगन इज ऑल्सो द कॉन्टेस्ट जो हुआ था, और वो कॉन्टेस्ट खत्म हो चुका है अभी, उसमें नहीं हम सबमिट कर सकते हैं. यू कैन चेक इंटरव्यू बिट पे, यू कैन जस्ट सर्च कोडेगन इंटरव्यू बिट सर्च कर लेना यार गूगल पे. ऑल राइट. सो अभी डायरेक्टेड के बारे में बात करते हैं. So directed graph है. Now the problem is, we do not want the distance from a node. We don't want the distance from hospital to node. अगर हमें हॉस्पिटल से वो चाहिए होती, क्या नाम है, डिस्टेंसेस चाहिए होती हर नोड के लिए, फिर तो हम क्या करते हैं, हम हॉस्पिटल से मल्टी सोर्स Dijkstra लगा देते हैं, राइट. बट द थिंग इज, वी वांट फॉर ईच नोड द डिस्टेंस फ्रॉम दैट नोड टू द हॉस्पिटल. does that make sense to you guys कि क्या प्रॉब्लम है यहाँ पे? बिकॉज इट इज अ डायरेक्टेड ग्राफ का मतलब, the distance from node to hospital will not be equal to the distance from hospital to node, right? So अगर हमें distance from node to hospital की जगह distance from hospital to node चाहिए होता, फिर तो हम हॉस्पिटल से जो भी नोड हॉस्पिटल है, उन सब हॉस्पिटल वाली नोड से मल्टी सोर्स Dijkstra लगा देते. बट that is not the case. So this is why we cannot directly apply multi-source Dijkstra. This is one simple small trick, जिसके बाद you can just simply use the code that I just wrote, multi-source Dijkstra वाला, और काम हो जाएगा. क्या कोई सोच पा रहा है वो? I'm having a look at both the chats, Unacademy as well as YouTube. Can anyone come up with the solution? What can we do? Something to do with the direction of edges. That is a big hint that I just gave you guys. Anyone? Yeah, Gagandeep. Just reverse the edges and apply. Just so the answer to the question is a simple trick that we can use is, I'm sorry, just reverse the edges, just reverse all of the edges while taking the input. If there is an edge from I to j, you do not add, let's say simply what you do is, uh, while adding the edges, just do this while m minus minus and uv comma scene uv. So instead of doing this, you just do this. So reverse the edges, reverse all the edges. So once we have reversed the edges, so in the new graph, if we calculate the distances, the shortest distances from the closest hospital to each city, we'll have the distances from each city to the closest distance, to the closest hospital in the original graph. So this is a trick that you can use, and then again, after reversing the edges, you just have to apply multi-sourced Dijkstra's algorithm from all of the hospitals, right? So I hope this isn't required to be coded, is it? I hope it is clear enough. We just have to change one single line, instead of this, just write this. All right. So I hope the solution is clear. Using thumbs up or yes is everything clear about today's class? Because okay, so Subhankar is saying no, don't clear. Subhankar, what exactly, like, did you not did you miss something that I said, or did you hear everything yet it is not clear? So what is it? I'll just speak it again. So the thing is, after having reversing every edge, every path is reversed. I'm not taking directed as undirected. I'm comment. This line is commented, man. Maybe I wasn't clear. This line is commented. Is it clear now, Shubhankar? I use this now. I'm sorry. Maybe I should have been more clear. This line is commented. So I'm just saying, instead of pushing v to u, just push u to v, because we want to add the reverse edge. All right. So I hope it is clear now. So any questions that you may have, I can try to address them in for the next 2-3 minutes, and then we'll just then I'll just sign off. So someone is asking, if a node is already visited, it can be updated with the shortest path. Please clear this. No, Gagandeep, if a node has already been marked, if a node has already been marked, it will not be updated again. We have discussed this, and I have tried to explain why. Please tell me if you want me to explain again, or is this answer enough? It will not be updated again. This is my answer. Yeah, okay, thank you for asking this. If you guys want to read about Dijkstra's algorithm more, or if you want the code that I just used, you can just simply go to cipalgorithm.com, and the code is almost sort of same, because I have also sort of studied Dijkstra's algorithm from there itself, so it will be helpful. सो गगनदीप यार, सिंपल सी बात है, देखो मैं तुम्हें हिंदी में समझाता हूँ. सिंपल सी बात है कि जब हम एक पर्टिकुलर नोड पे पहुँच रहे हैं, जब पहली बार वो नोड हम मार्क कर रहे हैं, सबसे पहले हम किसको मार्क कर रहे हैं? सबसे पहले हम सोर्स नोड को मार्क कर रहे हैं, राइट? सोर्स नोड को जब मार्क कर रहे हैं तो उसका डिस्टेंस तो ओरिजिनल ही है, विच इज़ 0. जब हम सोर्स नोड को मार्क करेंगे तो सोर्स से जहाँ जहाँ पे जा सकते हैं उनके डिस्टेंसेज अपडेट कर देंगे, है ना? फिर एक ओरिजिनल नोड पे पहुंचने से पहले, मतलब एक पर्टिकुलर नोड को मार्क करने से पहले, एक बार के लिए मान लो कि जो बाकी की सारी नोड्स हैं उन सबका डिस्टेंस ओरिजिनल डिस्टेंस है। एक बार ये मान लो, अगर ये मान के मैं प्रूव कर दूं कि जो करंट नोड मार्क कर रहे हैं वो उसका भी ओरिजिनल डिस्टेंस से निकल के आएगा, तो प्रूव हो जाएगा, राइट? मतलब आई एम ट्राइंग टू डू प्रूफ बाय इंडक्शन। जो पहली नोड है उसका डिस्टेंस ओरिजिनल निकल के आ रहा है विच इज 0। फिर मैं बोल रहा हूँ कि एक पर्टिकुलर नोड के लिए मान लो कि पहले की सारी नोड्स का जो डिस्टेंस है वो सही से निकल के आ गया है, अब वो अपडेट नहीं होंगी। अब अगर मैं प्रूफ कर दूं कि करंट नोड का भी डिस्टेंस सही से निकल के आएगा और वो अपडेट नहीं होगी, तो काम बन जाएगा। तो सिंपल सी बात है कि जब पहले वाली नोड्स पे हम थे जिनका डिस्टेंस मेरे से छोटा था, है ना, अगर जो मेरे से छोटे डिस्टेंसेस वाली नोड्स हैं, मैंने हर एक के लिए रिलैक्सेशन ऑपरेशन किया, हर एक पे जाके रिलैक्सेशन ऑपरेशन किया था ना मैंने, और जब वो मार्क हुई थी तब उनका डिस्टेंस भी ओरिजिनल था। अगर मैं अपनी छोटी वाली, अब से मेरे से जो कम डिस्टेंस वाली नोड्स हैं उन सबसे रिलैक्सेशन ऑपरेशन कर रहा हूँ, तो सबसे रिलैक्सेशन ऑपरेशन करके उनमें से ही किसी से तो शॉर्टेस्ट पाथ आएगा ना, तो जो भी शॉर्टेस्ट पाथ होएगा वो मेरे को मिल चुका होगा, क्योंकि जो भी नोड्स अभी मार्क होने वाली हैं उनका डिस्टेंस तो मेरे से बड़ा है। जो भी नोड अभी मार्क होने वाली हैं, जो भी नोड्स मेरे बाद मार्क होंगी, उनका खुद का डिस्टेंस ही मेरे से बड़ा है, तो उनके थ्रू मैं खुद को अपडेट कर ही नहीं पाऊंगा ना, बिकॉज उनका खुद का डिस्टेंस ही मेरे से बड़ा है। सोचो इस बात को। जब हम किसी एक पर्टिकुलर नोड पे जा रहे हैं तो उसका डिस्टेंस करंट नोड से तो बड़ा ही होगा ना। जब मैं नेबर्स को रिलैक्स कर रहा हूँ, उनका जो डिस्टेंस है वो करंट नोड से तो बड़ा ही आएगा ना। देखो यहाँ पे क्या कर रहे हैं, वेट प्लस डी ऑफ आई। यहाँ पे एक चीज़, बहुत इंपॉर्टेंट चीज़ मैं बतानी भूल गया, जो वेट है ये पॉजिटिव होना चाहिए, तभी इस तरह से एल्गोरिथम वर्क करेगा। नेगेटिव वेट्स के केस में वो वर्क नहीं करेगा। मे बी नेगेटिव वेट्स को लेके शायद कंफ्यूज कर रहे हो। हाँ, अगर घूम के आने में छोटा वो बिल्कुल ठीक है, तो घूम के आने में भी अगर छोटा है, ठीक है, मान लो 3 एक नोड है, उसको 1 से डायरेक्टली भी विजिट कर सकते हैं, बट 2 से घूम के आने पे वेट ज़्यादा छोटा आ रहा है। तो जब फर्स्ट टाइम 1 से रिलैक्सेशन करेंगे, जैसे जब 1 से रिलैक्सेशन करेंगे इस 3 की, मान लो जो 1 वाला जो वेट है वो 15 है, ठीक है, इसको मैं अपडेट करके लिख देता हूँ एक बार। मान लो ये 15 है, ठीक है, जस्ट अ सेकेंड, ये 15 है, तो ये पहले 15 होगा, बट जब 2 पे आएंगे, 2 का जो सोल्यूशन है, जो 2 का वो है, क्या कहते हैं, डिस्टेंस है, वो 3 से छोटा है, तो बट जब 2 पे आएंगे तब अपडेट हो जाएगा ना। 1 पे अपडेट नहीं हुआ बट 2 पे हो जाएगा। फिर देखो 7 प्लस 5 करेंगे, ये वाला भी जो नोड है ये 5 है, ये वाला भी जो है 5 है, तो अब इसका सही डिस्टेंस आ जाएगा 15 की जगह, अब ये 2 हो गया, 15 की जगह अब ये सॉरी 12 हो गया। सो चाहे घूम के आने पे छोटा डिस्टेंस हो, बट जहाँ से घूम के आओगे उनका डिस्टेंस तो मेरे से छोटा ही होगा ना। तो अगर उनका डिस्टेंस मेरे से छोटा है तो उनका रिलैक्सेशन ऑपरेशन ऑलरेडी कर चुके हैं, तो जहाँ से मर्जी घूम के आओ, रिलैक्सेशन ऑपरेशन तो सबका ही हो चुका है ना। जो भी मेरे, जिनका भी डिस्टेंस मेरे से छोटा है, सबका ही तो कर चुके हैं रिलैक्सेशन ऑपरेशन, किसी का मिस थोड़ी किया है। तो पहले 1 से किया तो रीजनल डिस्टेंस नहीं आया, फिर 2 से किया तो आ गया। अब 2 के अलावा किसी और से करने का कोई फायदा नहीं है, बिकॉज बाकी सबका डिस्टेंस तो मेरे ओरिजिनल डिस्टेंस से ही बड़ा है, तो उनके थ्रू आने का तो वैसे ही कोई फायदा नहीं होगा। तो दैट्स व्हाट आई एम ट्राइंग टू से। हाँ हाँ, रिलैक्सेशन के टाइम पे वापस विजिट हो चुका होगा, बट मार्क नहीं हुआ होगा ना। मार्क तो तभी होगा ना जब उसका ओरिजिनल डिस्टेंस आ चुका होगा। मार्क तो 2 के बाद ही होगा। विजिट और मार्क में थोड़ा शायद कंफ्यूज हो रहे हो। जब हम उसको मार्क करेंगे तब तक उसका ओरिजिनल डिस्टेंस आ चुका होगा। ऑल राइट, सो किसी ने बोला है इस अप्रोच का सोल्यूशन बताऊं। यार ये वाला क्वेश्चन मैंने सॉल्व नहीं कर रखा है, और मुझसे अभी इतनी जल्दी तो नहीं होगा। स्क्रीन कर रखा है या नहीं कर रखा है? ओके, सो मैंने क्वेश्चन नोट कर लिया यार, मुझे पता चल गया कि किसकी बात कर रहे हो। 257 डिव 1, ठीक है, मेरी हिस्ट्री में भी आ गया है। तो आई सी कि यार अगर मुझे क्वेश्चन अच्छा लगेगा तो आई जस्ट कवर इट इन वन ऑफ द फ्यूचर लेक्चर्स। अभी तो यार इसका सोल्यूशन डिस्कस करने में इतना टाइम लग जाएगा। होप यू अंडरस्टैंड दैट मयंक। ऑल राइट, ओके, मैंने नोट कर लिया, अगर हो पाएगा तो मैं फ्यूचर में कर लूँगा। ठीक है, चलो, थैंक यू गाइज, दिस वाज इट फॉर टुडेज क्लास। एंड कुछ ऐसे प्रॉब्लम्स का लिंक की बात कर रहे हैं, ऐसे प्रॉब्लम्स ऑलरेडी प्रीवियस क्लासेस में डिस्कस कर रखी है मेरे भाई। मैं ऐसी प्रॉब्लम्स डिस्कस करता रहता हूँ। लास्ट आई थिंक 3 ग्राफ प्रॉब्लम सॉल्विंग के हो चुके हैं लेक्चर्स, 2 हो चुके हैं, सॉरी एक परसों है, सॉरी एक कल है। सो ऐसी प्रॉब्लम डिस्कस होती रहती है भाई, टेंशन मत लो। चलो, ऑल राइट, so yeah, I think this was it from my side guys for today. Already 10 मिनट ऊपर भी हो चुके हैं। Thanks for thanks for being with me. I really enjoyed today's session, and I'm sorry for being stuck with English a little bit, but I just tried to sort of make sure कि the people who do not understand English, Hindi, they also sort of get benefit from this lecture. All right, thank you guys, thank you Mayank, good night Shubhankar, see you guys tomorrow also I'm having a graph problem solving session. Do join it. I'll see if I can cover this problem tomorrow, Mayank. I'll just read it after the lecture. All right, thank you, bye.